How's it going, everybody? It is Ethan, or Unknown Coder, and welcome back to Devlog index number 3. In this episode, we're going to go ahead and turn our HTML documents into Java objects, and then share that dependency across multiple services by building it up with Maven into a jar. And then we also get to the root of our problems with the auto wiring of our shared queue in Spring Boot. And finally, we're going to play around with some multi-threading of our application. That way we can consume the tokens by the tree builder as soon as the tokenizer emits it, which will actually allow us to finally build our HTML into the objects we created previously. As always, I'm Ethan, otherwise known as Unknown Coder, and I enjoy playing video games and working on side projects just like this one while I'm not training others to become successful software engineers. So without further ado, let's go ahead and hop straight into the video. We started out this video really strong, but things started to crumble quickly during our first coding session. We started by taking a peek at how we're going to create our DOM objects in Java. I did some experimenting and some test projects, and the thing that I was concerned about was the marshalling process with Jackson and Spring Web. I was primarily worried that Jackson would fail to contain all the child nodes when it converted the Java object to JSON. However, since the DOM is modeled as a tree, not necessarily a binary tree, we end up storing the child objects in a list. And then since we're storing all these child objects in a list, Jackson has no problem whatsoever with sending all of that data through the HTTP response bodies, which means that we're good to go. After a successful experiment, I created a new simple Maven project specifically to hold the models of our HTML objects. The reasoning behind this is that we are going to be sending and receiving HTML elements all over different services. Because of this, we had two options: either write the same model code over and over again in every single service that needs to receive or send an HTML document, or simply write and compress the DOM code into a jar, which can be shared across all of our services. You can imagine that the second option is probably best. Because of this, we whipped up the simple HTML document model, which simply stores the root element, which is the HTML element. Later, we will store more information about the document, most likely in maps. Then we modeled our HTML element to simply have an element name, some text content, and a list of child elements. Again, as we advance, we'll expand upon these models later. After writing all of this, we fussed around with Maven for a bit. It turned out that even though I'd been using Maven for a while, ever since I actually built this computer, I forgot to actually configure the environment variable, so my git bash and other command prompts weren't actually recognize the mvn command. After we fixed that issue, we did some other tinkering and research until we finally got the project to build. The most difficult part of all this was actually getting the command correct to actually include this jar in that local Maven repository. However, I was sure to document all the steps, that way we can always rebuild and include the new jar anytime that we change our HTML DOM objects. And then finally, after all of these minor wins, our excitement for the progress quickly came crashing down. We turned back to the issue where we were trying to fix previously with the shared token queue between the parsing class and the tokenize class. After banging my head for a while, I realized that I was missing a warning in the console that said Spring cannot auto wire a static field, and then it all hit me. On its own, this would not have been an issue. However, I was not very smart whenever we set up our tokenizer state, and everything inside of that tokenizer class was actually static. That means that we had to refactor everything inside this tokenizer class, and because of this, I ended up rage quitting. And also, something else that I kind of decided on a whim after this was that I was not really enjoying coding with VS Code. That's primarily also why I missed this issue, because it wasn't highlighted very well. And the Spring initializer was not actually fully featured as the online counterpart was. Because of this, I went ahead and switched over to Eclipse and installed the STS3 plugin, which gave us all the good stuff from the older version of STS without the overhead of STS4. Are you enjoying the content? Maybe learned something new? Please make sure to hit that like button below if you are in fact joined, or if you're not, go ahead and leave a dislike. Also, if you have some feedback, good or bad, I would love to hear it in the comment section below. All user interaction helps me out a ton with this YouTube algorithm. So while you're at it, also make sure you hit the subscribe button below. It's free. And if you hit the bell icon, you can also give you alerts when I post new content like this. So let's get back into the video. Once again, we went back to work on live stream on Wednesday. Like I previously mentioned in the last section, I made a switch over to Eclipse with STS3 installed because I felt it could give me a lot better initialization control. With this, I went back through and recreated our project, except with a more well thought out package naming scheme. And now I'm a much bigger fan of our organization and package structure. After we recreated the project, I went back through and rewrote most of our code with minor refactoring here and there. I separated out our parsing states in our models into two separate packages. I also renamed all of our token models to include token in the name of the class. That way we know for sure that we're working with a token type. Our different state enums essentially just got copy pasted except into the states package. This is because I'm sure we'll probably need more states later on. Our HTML parser and tokenize class got their own packages as well. This is where we'll start putting extra classes that we need, whether they be helper or utility classes for later on down the road. The biggest bit of refactoring that we had to do was inside of the tokenizer class. Like we stated in the previous video block, we had to change everything from static scope to instance scope. This brought on tons of compilation errors that we had to solve. This means we just had to take the time to fix these and then we were good to go. After switching our class states and behaviors to instance scope, we were able to create a configuration class to have Spring create a bean of our embedded token queue. Since this is a singleton instance, we can actually pass this queue around to different services and it'll be the same exact queue, which is exactly what I wanted. So now we can pass new tokens into the queue and our tree building method can see those tokens and process them into the corresponding pieces of HTML that we need. After we got all of our shared queue working, I realized that we had run into a new issue, and that is that in the real algorithm, we're supposed to process the tokens as they come in, but with the current logic, we're going to tokenize the entire page and then start processing the tokens after that entire page is done. So to fix this, we need to turn to threads and one of the most classic threading problems, the producer and consumer problem. So what is this producer and consumer problem? This is a thread synchronization problem that many young programmers learn about in school or early on in their careers. The problem states that there are going to be two actors in one shared resource. One actor is acting as a producer, which does exactly as it sounds, produces some objects and adds it to the shared resource. The other actor is acting as a consumer, which again does exactly as it sounds. It consumes any objects that get placed inside that shared resource. The rules for the producer are that it should only produce objects and share them on the shared resource while the shared resource is not full. And the rule for the consumer is that it should only consume resources from the shared resource whenever that resource is not empty. Because of this, we must synchronize the shared resource and make the producer or consumer wait until it's their turn to either produce or consume the content. So how does this actually apply to our project, you may say? We're going to create a thread to act as the producer, and we'll also create a thread to act as the consumer. In our case, the shared resource will be the emitted token queue, and we must use the synchronize keyword in Java as well to make sure that the resource gets shared between the threads. We're going to use the wait and notify keywords to actually communicate between these threads in Java and tell the producer and consumer when it's their turn to actually act as that queue. So with that being said, let's go ahead and hop into our next section. Before moving on, I just want to let everyone know that as soon as I get moved and situated, I will be actually live streaming on Twitch at least every single Saturday morning on this project, and possibly even playing games during the week. So be sure to head over to my Twitch and follow me at twitch.tv/unknowncoderyt. Also, to keep updated with where my videos are and streams are, follow me on Twitter at twitter.com/unknowncoder. In our final coding session, we finally tackled the logic to tokenize and build our DOM tree in parallel using the producer and consumer logic we explained previously. To do this, we must create custom threads in our Java program. It's actually very simple to create threads in Java. You must just extend the thread class and then implement the logic you want the thread to run inside of the run method from the thread class. We start out by extracting the tree builder method from the HTML parser into its own class that will act as our consumer thread. We write the consume token method to be the logic that we want to run inside of our run method. The logic behind the consume token is simply to check to see if there's an emitted token inside the queue. If there is no tokens, we'll wait and get notified by the producer when there's tokens available. If there are tokens available, we will consume them. And for now, that just means that we're going to remove them and notify the producer thread that we have emptied the queue and it can make an attempt to create more tokens. We must throw this logic into the run method and then run the thread until we have no more tokens. The issue we ran into here is that we have no way to actually know when there's no more tokens left inside of the tokenizer. So to fix this, we will auto wire a tokenizer object into the tree builder class, and then we also added a boolean that will eventually turn to true whenever we're out of characters inside the tokenizer class. With the simple implementation of a getter method, we can actually get access to that variable outside of the tokenizer class and use that inside of a while loop of our run method to kind of know when to stop the loop. Next, we went back to the tokenizer class because it will act as our consumer method. We just need to make a couple of changes. So first, we extend the thread class and make some minor changes to the tokenize method. We again use the synchronize keyword on our shared queue. This time, instead of checking to see if the queue is empty, we're going to see if it's not empty. This time around, if the queue has items in it, we're going to wait to hear from the consumer whenever they finish emptying the queue. Otherwise, it'll run the same logic we've been working on to produce tokens and then notify the consumer when they've produced a new token. With these two set up, we can go into our HTML parser class and set up the tokenizer thread and the tree builder thread to run concurrently until they have created all of the tokens and consumed all of the tokens. Once both have finished running, their logic in the threads will join back together into the main process. Now we just need to figure out the actual tree building logic, which we'll take a look at in the next episode. After this, we wrapped up the coding session with some of my famous refactoring. The first thing I did was move the preprocess method over to the HTML parser class. This is because the algorithm says to do so and I do as the stone guide. Then I took another trip in the tokenizer class to save some lines of code since this class is going to be massive very soon. I went through all of the if statements inside of the change state method and extracted any of them that I have not yet extracted into a method, and I also created a new class to hold these utility methods. It seems like a lot of extra work at the time, but in the long run it should help the readability of our code because now each if statement says exactly what it's checking, and it's most likely going to reduce the code duplicated because there's going to be many if statements that check for the same exact checks.